In this lesson, we're going to talk about static class members. And so statics are something you've seen before and have been using to some degree in certain situations, but really we haven't fully explained what they are or shown you how to use them yourself in your own code. You've primarily been using static either in certain situations where you've kind of learned to use it. So, for example, in something like a main method, public static void main. You've learned to use the static keyword there. And you've also been using static methods from time to time, but primarily in ways where it wasn't really clear exactly what was going on. So we're going to clarify some of those things and introduce you to statics, explain why they're useful in Java, and also show you when you should use them in your code. So just to kind of introduce the concept of statics, um, we'll talk about static class members. So a static can be either a property or a method. And we've primarily talked about classes as blueprints for objects. So here's an example of a class, a post class. This represents a blog post, and you'll be working on this class in the near future. But notice that it has a few properties defined at the top of the class: a title, a body, an author, created. And these are all properties that every single instance of the post class will own. So if I use the constructor and the new keyword to build a bunch of different posts, each one is going to have a different title, a different body, a different author, potentially at least, right? They each have their own copies of those fields that they can then have different values for. So the main difference between static and non-static class members is just that. So a static member is one in which that property or that method belongs to every instance of a class. So we're going to look at this particular class counter to kind of illustrate some of these ideas. So here I have two different integers that are declared at the top of my class. The first one is declared as private static int static counter, and it's initialized to 0. The second one is just a private int, and it's called instance counter. So we refer to an instance as an actual object that has been created from a class, that has been created from that class blueprint using a constructor. So that's what we mean when we talk about an instance. And so when we talk about statics, we'll distinguish between an instance property and a static property. An instance property belongs to a specific instance of an object, an actual object. A static property or a static method belongs to all instances at the same time. It belongs to the class itself. So this is why statics are sometimes referred to as class members. So you might hear something like a class variable or a class method, and that is used synonymously with the word static. So let's kind of go through this example and give you a feel for how static properties and methods work in Java. So in my class counter here, this is kind of somewhat of a contrived example just to illustrate the dynamics of statics. This isn't something you would probably write for a particular use case, but it does kind of cleanly illustrate the dynamics and the differences between static and instance properties. So we just talked about these two static properties at the top. I also have some methods. I have an increment static, which simply adds 1 to the static counter. I have an increment instance, which adds 1 to the instance counter. And then I have getters for both of those properties. Notice here that on the two methods that deal with the static counter, which is, again, our static property, the methods themselves are also declared static. Okay, so we'll come back and talk about that in a second, but let's continue to look at the rest of this class. Okay, so I have my two getters. Below that, I have a main method. So we've used main methods a lot in this class so far, and not every class that you have will need or require a main method, but they can be useful just to run code. So every main method, as you've seen, has to have the keyword static. Okay, and this basically lets us run the main method without creating an instance of our class. So you've used this so far, and the way we've done this so far is to when we want to run a Java class and execute the main method, we'll come over and right-click on the class and say run as Java application. That then fires up that main method and executes the code within that method. So, pardon me. When we've done this, we haven't had to create an actual instance of a class in order to execute the main method. That's because the main method belongs to the class itself. It's a static. So that's just kind of how that's been working. You've been using this, but not really necessarily known how it's worked. So let's look at a little bit how this main method illustrates the properties of statics for our particular class. So within main, I create two instances, two objects. I create a counter all and counter evens. Okay, so these are just two individual different objects. Okay, these each have their own copy of the non-static instance property instance counter. So each of those classes has their own instance counter. Each of those objects, rather, has their own instance counter. But they're going to share the static counter. Static properties, as I said, are shared by every instance of a class. So both of these objects will share the static counter, and we'll see how that works in a second. So for these counters, I'm going to do a couple things. I'm just going to kind of generate some different random numbers and then call the increment methods to change the values of the increment properties, of the counter properties within each class. So I generate a random integer max1 and then a random integer max2. Notice here that when I'm doing this, I call math.random. So this is actually an example of using a static and one that you may have used in your code already. Math is a class that's part of one of the core libraries in Java, the core packages in Java, and it has a random method. That random method is itself static. So when I call a static method, I do so by using the name of the class and then dot the static method. I don't have to have an instance. I don't have to create an instance of the math class by saying new math or anything like that. I don't do anything like that to create an object of type math. I just use the static method itself. So this is an example that you may have used already, and this actually is a static method in the math class. So I use that random method to generate two random integers. And then I'm going to create a loop. This loop is going to just loop whatever this particular integer is. That's the first random integer. It's going to loop that many times. It's going to increment the all counter every single time it goes through the loop. So that's going to just count how many times we go through the loop. And then whenever we hit an even integer, we're going to increment the evens counter. So that will only count the evens. So really this should just give us about half of what the counter all gives us. Down below, I use the other random integer that I generated in order to increment the static counter. So this one will just get incremented every single time, and we're going to see that this counter, how this differs from the others. Notice again that I'm using the counter class. I'm not using, say, counter all to do this. I can do this actually. This Java technically will allow me to do this, but as you can see within Eclipse, this is a really bad thing to do. It's generally discouraged, and I don't think you'll find a single Java programmer that thinks that this is a good technique to use. So in this particular main method, I essentially have three different counters going on, three different things being counted. One of the counters is the instance counter property of counter all. The other is the instance counter property of counter evens. The third is the static counter that belongs to both of them. Okay, so that's this counter down here that's incremented when I call increment static. Recall that increment static just refers to that static counter. Okay, so let's go ahead and run this and just see what happens. It's nothing terribly complicated. Okay, so we see that it looks like our first random integer was 33, the second one was 30. So we had counter all totaling up 33 increments, counter evens totaling up 17, which is again roughly half, and then counter static counter totaled 30. So those three different counters worked in different ways, and so you can see that the how that played out with counter all having its own instance property, counter evens having a different one. So these two numbers, 33 and 17, each come from this class or this specific property of each of those objects. So each of those objects has their own instance counter property, and you can see that because these two numbers are different, right? This one reflects the instance counter property for counter all. This one reflects the instance counter property for counter evens. However, they both share the property static counter that's incremented by the increment static method. Okay, so we can see that that again is yet different. And if I actually went in here and did something like counter all, which I'm technically allowed to do, and rerun this code, we can see that it'll still work, and I still get yet a different number. But again, this is really just not a good practice. But this shows you that that I can actually use, for instance, the static property, and both of the instances of my class here, both of the counters have access to that static property. So let's look at, just to show this one more time, let me go down here. When I print the static counter, let me say counter evens and print that. So this will show you that I'm incrementing the static counter on the counter all object, and I can print it on the counter evens object, and those will actually be the same. Let's go ahead and just show you that. Okay, see? So even though I never said counter evens dot increment static, that static counter still has a non-zero value. That just shows you that when I do increment static up here by calling it off of the counter all object, it's actually incrementing that this property which belongs to all of the instances of the class. So that just shows you that works. I'm going to go put this back the way it's supposed to be. Okay, so to recap, static properties are properties that we declare static in our class, and those properties belong to the class itself. When I create an instance of the class, those properties are not generated for that particular instance. They belong to the class itself. A static method is then a method that, again, belongs to the class itself. That method does not belong to a specific instance of the class or a specific object, but it belongs to all instances of that particular class. So one thing to notice here is that when I have static methods, I can't refer to instance properties. I can't say this dot instance counter. Okay? I can't do this. And the reason I can't do this is because when I'm using a static method, I actually don't have a this. There is no this. The static method belongs to the counter class, right? So I don't have an object that I've created from that class as constructor that I can refer to as this. It just doesn't make sense to use the keyword this, to use instance properties within a static method. So Java will prevent you from running this code. It'll prevent it from compiling, and Eclipse gives you this error. Cannot use this in a static context. All right, so that's just another thing to be aware of. If you create a static method, that method can and should only refer to local variables and other static properties. You cannot refer to instance properties. Okay? Yeah, so that's it. So one more note about statics is that you can see that in this example I've created a class that extends counter, and I've created another main here that the counter itself still belongs to the parent class. The static properties still belong to the parent class. So while I can do something like counter child dot increment static and then counter child dot get static counter to both increment that counter and then to print it out, I'll show you them in a second when I run this, that property actually still belongs to the class that it was declared in, the class that counter child is extending. Okay, so let's just see that. Okay, so we can see that these are the same. So if that wasn't the case, if counter child had its own kind of static reference, then one would be 0 and one would be 10, right? So in particular, the first one would be 10 and the second one would be 0, but we can see that those are the same. So when you're using statics, just remember that this is something that's kind of different from the way we've thought about object-oriented programming so far, where every single object has its own copy of everything in the class declaration. Here, we can see that That's not the case with statics. Statics belong to every instance of the object, and they don't exist within the specific instances. They exist within the class itself. All right, so you're going to go ahead and use statics in your code and get familiar with them and get comfortable with them and find them to be very useful tools for you in your Java programming.